In this episode, we move into a part of security analysis that becomes especially important when a suspicious file looks dangerous, but not enough is known about it from a simple inspection alone. Dynamic malware analysis platforms, often discussed as sandboxing, help defenders observe what a file, script, or other object actually does when it is allowed to run inside a controlled environment. For a brand new learner, this topic matters because many threats do not fully reveal themselves while sitting still. A file may look ordinary at rest, yet behave very differently once it opens, reaches out across the network, changes files, launches child processes, or tries to establish persistence on a system. Sandboxing gives analysts a safer place to watch that behavior unfold without exposing a normal user device or production server to the same level of risk. Once you understand that idea, dynamic analysis stops sounding mysterious and starts looking like a practical method for replacing guesswork with observation. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. At a basic level, dynamic malware analysis means examining a suspicious object by running it and monitoring its behavior instead of relying only on what can be learned from static inspection. Static review can reveal a great deal about file type, structure, metadata, and suspicious content, but some threats are built to keep their real purpose hidden until execution begins. That is where dynamic analysis becomes useful. Rather than asking only what this file appears to be, the analyst begins asking what this file tries to do when given the chance. Does it create new files, alter security settings, reach suspicious destinations, access memory strangely, or attempt to survive a reboot? These questions matter because malicious intent often becomes clearest through action. For beginners, the most helpful way to think about sandboxing is as a safe observation room. The suspicious object is allowed to behave in a controlled setting, and the analyst watches that behavior closely enough to decide whether it reflects normal software activity, obvious malware, or something ambiguous that requires deeper investigation. A sandbox is called controlled for a reason, and that control is one of the biggest reasons organizations use this approach. If a suspicious attachment is opened directly on an employee laptop, the security team risks letting the threat execute in a real business environment before they understand what it is capable of doing. In a sandbox, the goal is different. The object runs in an environment designed for observation, restriction, and containment, so that even if it behaves maliciously, the damage is limited and the behavior can be studied. The sandbox may imitate a normal endpoint closely enough that the file believes it is running on a real system, but the surrounding controls are built to capture evidence and reduce the chance of broader harm. For a new learner, this is a major point. Sandboxing is not about trusting suspicious content. It is about creating enough realistic conditions for that content to reveal itself while also keeping the organization from paying the full price of letting it loose on a normal machine. When a file runs inside a sandbox, the platform is usually watching several kinds of behavior at once. It may observe which processes start, which files are created or modified, what registry or configuration changes are attempted, what network connections are made, whether the object reaches out to external destinations, and whether it tries to download or launch additional content. The platform may also watch for persistence behavior, privilege-related actions, suspicious use of built-in system tools, or signs that the file is attempting to evade detection. This matters because malicious software rarely limits itself to one simple action. It often works through chains of behavior, where one action creates the conditions for the next. A dropped file may launch a script. That script may contact a remote destination, and that communication may lead to more downloads or data theft. Dynamic analysis helps reveal those relationships. For beginners, that is one of the biggest advantages of sandboxing. It lets the analyst see not just isolated events, but an unfolding pattern of behavior that tells a more complete story. One especially important lesson for CySA Plus learners is that behavior often matters more than appearance. Attackers know that defenders examine file names, extensions, icons, hashes, and other visible clues, so they often work hard to make malicious content look routine. A document may appear like an invoice, a resume, or a project update, while the real danger is hidden in code or embedded content that only becomes active under the right conditions. Once such a file runs in a sandbox, the disguise becomes less important than the actions it takes. A supposed document that launches a command interpreter, writes files into unusual locations, and attempts repeated outbound connections stops looking like an ordinary business file very quickly. Dynamic analysis is valuable because it exposes that difference between what a file claims to be and what it actually does. For a beginner, this is a useful mindset. In security, trust should not rest only on how something looks. Real confidence comes from understanding behavior and comparing that behavior to what a legitimate object should reasonably need to do. Dynamic analysis platforms are particularly helpful with modern phishing and malware delivery methods because so many attacks arrive through common business channels. An employee might receive a file by email, download it from a shared workspace, or retrieve it from a link that seems connected to normal work. At first glance, the content may appear relevant to a real process, which is exactly why it is dangerous. A sandbox allows the security team to examine the object without relying on a user to make the right call under pressure. If the file tries to launch a hidden process, contact a suspicious domain, or pull in a second-stage payload after opening, the platform can capture that evidence before the object reaches a broader set of users. For new learners, this explains why dynamic analysis is often part of a layered defense strategy. It sits between blind trust and full compromise. Instead of simply allowing or denying based on a quick guess, the organization can observe the content in action and make a stronger decision grounded in actual behavior. Another reason sandboxing matters is that many malicious objects are designed to act in stages rather than reveal everything immediately. The initial file may do relatively little on its own. Its real purpose may be to establish a first foothold, retrieve additional tools, contact an outside controller, or test whether it is running in a suitable environment. If analysts only inspect the first visible file and stop there, they may miss the next stages that reveal the true seriousness of the threat. Dynamic analysis helps close that gap by showing whether the initial object behaves like a gateway to something larger. A seemingly small attachment may spawn child processes, alter scheduled tasks, change startup behavior, or reach external services that support additional compromise. For beginners, this staged behavior is important to understand because it explains why some attacks look unimpressive at first. The danger may not be in the first visible action alone. The danger may be in the chain that begins once execution opens the door for the rest of the malicious sequence. The network behavior observed in a sandbox is often especially useful because it helps analysts see whether the suspicious object is trying to communicate with something beyond the local system. A malicious program may attempt to contact a command source, report back that execution succeeded, download more components, or exfiltrate information gathered from the host. Even if the sandbox limits or simulates that communication, the attempt itself is meaningful. It shows intent and can reveal infrastructure, timing patterns, or destination characteristics that support broader detection across the environment. For a beginner, this is a strong reminder that malware is rarely just a local file problem. Many attacks depend on communication, and the network side of the behavior often helps confirm whether a suspicious object is merely broken software, an aggressive but legitimate tool, or something clearly malicious. Dynamic analysis platforms, therefore, do more than watch local changes on the host. They also help reveal whether the object is trying to become part of a larger attack chain that extends beyond the single system where it first ran. At the same time, attackers know sandboxes exist, and many threats are designed to notice or avoid them. Some malicious files check for signs that they are running in an artificial environment, such as unusual timing, limited user activity, virtualized hardware clues, or a lack of the ordinary artifacts that appear on real employee devices. Others delay their actions, requiring time, clicks, or specific conditions before they behave maliciously. This matters because a quiet run inside a sandbox does not always prove a file as harmless. Sometimes it only proves the file chose not to reveal itself under those conditions. For a new learner, this is an essential warning against overconfidence. Dynamic analysis is powerful, but it is not magical. The organization must interpret results carefully and understand that some threats are deliberately patient, selective, or evasive. A clean result may reduce suspicion, but it should be weighed alongside static analysis, email context, endpoint telemetry, and other evidence rather than treated as unquestionable proof that the object is safe. Because of that evasive behavior, good sandboxing is often about more than simply opening a file once and watching for a few seconds. The environment may need to imitate realistic user conditions, allow enough execution time, and expose enough ordinary system features that the suspicious object behaves naturally instead of staying dormant. The platform may also need to test multiple file types, delivery methods, or interaction patterns, since different threats activate in different ways. This does not mean the analyst must manually recreate every possible situation. It means mature dynamic analysis recognizes that realistic context matters. For beginners, the key lesson is that observation quality depends on environment quality. If the sandbox looks too artificial, some threats may hide. If it looks more like a believable endpoint, the suspicious object is more likely to reveal its intent. This idea also explains why sandbox findings are often discussed with some caution. Analysts care not only about what the file did, but also about the conditions under which that behavior was or was not observed. Dynamic malware analysis platforms are most effective when their results are connected to other parts of the security program rather than treated as isolated evidence. If a sandbox report shows that a file contacts a suspicious destination, drops a new executable, and creates persistence behavior, those findings become more powerful when compared with email alerts, endpoint events, firewall logs, or user reports. A malicious attachment observed in the sandbox may help explain why an endpoint later showed unusual process activity. A suspicious domain revealed during execution may help threat hunters search across network records for related connections from other hosts. For a CySA Plus learner, this connected view matters a great deal. Security tools are rarely strongest alone. Their real value emerges when one source of evidence enriches another. Sandboxing is not just about understanding one file in a vacuum. It is also about turning the behavior of that file into broader detection, investigation, and response opportunities across the environment. There are also practical operational benefits to sandboxing that matter beyond pure threat confirmation. A dynamic analysis platform can help reduce analyst workload by providing a consistent first look at suspicious objects and highlighting the behaviors that deserve human attention. Instead of every file requiring the same level of manual review, the platform can separate ordinary items from those showing risky actions such as outbound communication, credential-related access, or suspicious process chains. This does not remove the need for analysts, but it helps them spend time where their judgment matters most. For beginners, this is important because real security operations are full of competing demands. Teams cannot study every attachment or download in the same depth. Sandboxing helps triage that problem by producing observable evidence early. It turns uncertainty into a more manageable decision about whether content should be blocked, escalated, further analyzed, or treated as low concern based on what it actually attempted to do in a controlled setting. Several misconceptions can make this topic harder than it needs to be if they are left uncorrected. One misconception is that sandboxing is only for very advanced malware researchers doing deep reverse engineering. In reality, the underlying idea is practical for general security operations because many teams simply need to know whether a file behaves suspiciously enough to justify blocking, containment, or deeper analysis. Another misconception is that a sandbox provides a final answer every time. It often provides strong evidence, but results can still be incomplete, especially when a threat delays execution or looks for specific triggers. Some learners also assume that if a file shows aggressive behavior in a sandbox, the case is closed and nothing else matters. In practice, defenders still need to connect those findings to the wider environment. A malicious object may be confirmed, but analysts still need to know who received it, where else it appeared, what systems touched it, and whether any endpoints already executed it outside the controlled platform. A simple example helps tie the ideas together. Imagine an employee receives a file that appears to be a routine business document tied to an ongoing project. Static inspection suggests the file is unusual but does not fully explain its purpose. The file is then submitted to a sandbox, where it opens a visible document to distract the user while quietly launching another process in the background. That process creates a file in a startup location, attempts repeated outbound communication to a rare destination, and tries to retrieve an additional payload. Suddenly, the picture is much clearer. The object is not just an odd file. It is part of a delivery chain designed to establish persistence and begin external communication after the user opens what looks like legitimate business content. For a beginner, that example shows why dynamic analysis matters so much. The true nature of the threat became clearest not through appearance, but through observed behavior under controlled conditions. As you bring all of this together, the main takeaway is that dynamic malware analysis platforms give defenders a safer and more informative way to see how suspicious content behaves when allowed to execute. They help expose process activity, file changes, persistence attempts, network communication, and stage behavior that static inspection alone may not reveal. Sandboxing is powerful because it turns unknown objects into observable actions, yet it must still be used with realistic expectations because some threats hide, delay, or adapt when they suspect analysis. For someone studying CySA+, the lasting lesson is that sandboxing is not about blindly trusting suspicious content enough to run it everywhere. It is about building a controlled place where the organization can learn from execution without handing the attacker the full advantage of a real production environment. When used alongside other evidence sources, dynamic analysis becomes a practical bridge between suspicion and understanding, helping security teams make stronger decisions before a dangerous file becomes a real business incident.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.